Hello guys and welcome. In today's video I'm going to just do a quick video on how to find prime numbers within a given range, that is from 0. In this case we'll be writing a function that will find prime numbers between 0 and a given number, which will be a parameter in our function. We will write our function in Java, so stay tuned. If you are new, please subscribe and also click the notification bell. And if you guys want us to write the same function in Python, we can also do so if you just comment in the comment section below. Now I will use VS Code, which is my favorite IDE or editor, and I will create a class in a file named app.java. So, and then we'll create our main function, which we will use to test our function that will be used to find prime numbers. We will call our function find prime numbers. So let's say we are finding prime numbers from 0 to 30. That is our argument in this case. So let's create the method, and then instead of void we need to return a list of integers. We need to return a list of integers, and then first of all we say if let's call it n for integer n. So if the highest possible number is greater than 2, if n is greater than 2, then it means our first prime number will be 2. So we will add to our list, which we call result, which we have not created. I'm sorry for that. If you are getting lost, let me just create list. Let's call it result, new array list, new array list. So and that is what we will return. Actually we will return the result. So we can just import. So if n is less than 2, then obviously there is no prime number that is less than 2, and we will return the empty result list, because our list is empty so far. We'll just return it empty if that is the case. Now, but if it is greater than 2, we need now to look through the numbers that are greater than 2. So we start from 3. So I is equals to 3. We initialize at 3, and then should be less than n, of course, non-inclusive, that is, and then we will increment by 2, because we'll only be looking for the odd numbers. Clearly there is no prime number that is an even number, so there is no need for us to look for the odd numbers, for the even numbers, sorry. Now, and then we will create a Boolean variable called as factor, which we will initialize with false until we find a factor. So but those factors, the factors of a number, can be anywhere between 2 and the square root of that number. So we should not just look for the number all the way to that number. By the time we reach the square root of a number, we should have found all the possible factors. So root is equals to, or we assign it to, cast it to integer. We are casting the square root of I and calling it root. Now for the factors which we have said starts from 2 but is obviously less than or equal to that root, like 49 for example. 49 I believe has only 7 by 7, so it is not a prime number. So so now we are starting from 2, but looking at it, we can actually start from 3 and do the same thing that we did, that is increment by 2. Because if you look at it again, if we are looking for odd numbers, it is impossible for an odd number to have a factor that is an even number. So clearly there is no need for us to look for factors of an odd number within the even numbers. So it is not possible. So then what do we do with 2, for example? Now that in fact there is no need for us, because if a number is divisible by 2, then it is not possible for us to find a number that is possible, to find a number I that is divisible by 2, because we are only looping through the odd numbers. So therefore there is no need for us to check for 2 or factor 2. No, we can never find a factor 2 within the odd numbers. So if I modulus j, if when we divide the remainder is exactly 0, then it means it has a factor. So we say as a factor we set it to true and then break. Now there is no need for us to continue looping through the inner loop, that is the loop j from 3 to the root, because once we find a factor, even if it is just 1, there is no need to continue looking for other factors. Having just found 1, we know that that is not a prime number. We immediately exit or break from the loop, and then after setting as factor to true, and then when we come out here outside the loop, the inner loop, we need to check now if it doesn't have a factor. If as factor is false, then that means we have found a prime number and we need to add our number I to the list of prime numbers. And that is it. That is it, guys. Let me just expand just in case someone is struggling to see. So we check first of all n, if n is greater than 2, because if n, for example, is 2, then that means the only prime number between 0 and 2 is nothing. There is no prime number because we said it is not inclusive. So unless so if it is less than 2, if it is greater than 2, yes, our first prime number should be 2. If it is less than, no, there is no prime number. We return an empty list, and then we loop through the odd numbers To check if any one of them is a prime number, we create a Boolean variable which we initialize with false, and we will set it to true once we find a factor. And that factor should be any number between 3 and the square root. Now, so if when we divide that number with any factor, any possible factor, we get a remainder of 0, then it means it has a factor. We set as factor Boolean to true, break out of the loop, because there is no need for us to go through the loop again to finish the loop when we have already found a factor. So once we've broken out of the loop, or if in case we do not find and we go through the loop and we do not find a factor, then it means it is this as factor Boolean will be false. So when we reverse it with the not, so when we reverse, it becomes true, and then that means it is a prime number. We add the number as a prime number. Now let's test our function. Find prime numbers. It should return a list. Static list of integers. It should return a list of integers. We will print it. We don't want to just call it. We want to print it. And then let's see. So you can see the prime numbers between 0 and 30 will be 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Now, what about 50? So let's run. Yes, and those are the prime numbers between 0 and 50. So that is the most efficient way of writing a function to find prime numbers. So if you learned something, guys, give me a thumbs up, like my video, share, and also click the notification bell. Also subscribe for such great content. And if you guys want us to do the same video in Python, we can do it. Only comment in the section below, and I'll catch you guys in the next one. Bye bye.